Last stage we lived in raw NumPy. Dot products, norms, list as queue fitting a line through points. Powerful, but every column was just an anonymous axis. Real data has names, a user ID column, an age column, a plan that says free or pro. This episode we put labels on the array. We build a data frame and we learn the 3 calls that tell you what you're holding before you trust a single number. Picture a NumPy array, a clean grid of numbers, no headers, row 2 is just row 2. Now slide a strip of names across the top, user ID, age, score, active, plan, and a numbered index down the left. Same grid. But now every cell has an address. You can say out loud, that strip of labels is the entire difference between an array and a data frame. Here's the part NumPy can't do. One NumPy array is one D type, all ints or all floats, never both. A data frame is a row of series stitched together, and each series carries its own type. The id column stays integer, score is float, active is boolean, plan is text, mixed types, one table. That's why tabular data lives in Pandas, not raw NumPy. A column pulled out alone is a series, values plus that same index, like a single labeled vector. Stack the columns back together, sharing one index, and you're back to the data frame. So a data frame is just series that agree to share an index. Hold that picture, it makes every selection, every group by, every merge later make sense. Before you compute anything, you interrogate the frame. Head shows the first 5 rows, a sanity glance. dtypes lists what each column truly is, so you catch the number that secretly came in as text. Describe runs count, mean, std, min, max, and the quartiles on the numeric columns. A full statistical X-ray, one call, no loop. Here's the program. Seed with m.random.default rng7. Build 5 columns straight into p.data frame. Arrange for IDs, integers for age, normal for score, rounded to 2 places. A boolean from random o 0.5. And choice over 3 plan names, 6 rows, mixed types, 0 downloads. Watch the dict. Each key becomes a column name. Each NumPy array becomes that column's values. Pandas lines them up against a shared default index 0 through 5. No for loop builds this table. You hand Pandas the columns, and it assembles the frame in one shot. Now the 3 interrogators. df head prints the rows. df dtypes reports the type per column. And notice it's not one type for the whole thing, it's 5 different ones. df.describe runs the numeric summary, and we round it to 2 decimals, so the figure and the terminal agree exactly. Run it. Shape comes back 6 by 5, 6 rows, 5 columns. The head shows user IDs 1001 through 1005, ages, scores, the active flag, the plan. Everything you typed now addressable by row and column name. Read the dtypes block. User ID and age are int64, score is float64, active is bool, plan is a star. Pandas label for text, what older versions called object. 5 columns, 4 distinct types, 1 table. That single column of differing types is the thing a NumPy array fundamentally cannot represent. And describe hands you the numbers free. Score has mean 67.14, std 1030, min 5810, max 86.08. No accumulator, no division by count. One method call did the whole summary across exactly the numeric columns and skipped the text and boolean ones. That's the whole idea. A data frame is NumPy with names and mixed types, and head dtypes describe are how you read it before you trust it. Mean, score 67.14, reproduced to the digit. Next, we stop looking at the whole frame and start pulling pieces out, lock, eloc, and boolean masks for selection.